Hey guys, today we're going to be talking about slope in context. We're going to be given some real world situations and we're going to find what the slope is. And then we're also going to say what that means in the context of that situation, that real world situation. So you guys should already know that we talked about before that slope is your rate of change. Also that m variable. And here we have the slope formula, y2 minus y1 over x2 minus x1. So we can use this piece of information about the slope to help us interpret it in context. Your y variable is related to your dependent variable, and your x variable is related to your independent variable. We can use that information to help us find the units of our slope by putting together the units of the dependent variable and the units of the independent variable. Typically, but not always, when we do this, we're also going to make sure we can write it as a sentence. So we can't use this division bar in our sentence. So usually you're going to think of it as the word per. And that's how we're going to say it out loud as we start to take a look at some examples here. Example 1, we're going to find the slope and then interpret it in context. So we have the graph here talking about the estimated maximum heart rate of a person based off their year, age, in years, and then their maximum heart rate. It's worth noting that here, this is going to be your independent variable. It's on your x-axis, which is relates those together. And then we're also going to note that this is our dependent variable because it's on our y-axis. And that's going to help you guys identify what your independent and your dependent variable is, which is going to help us in turn make sure we can interpret it in context and include the proper units. So our slope is m equals, so the dependent is our y's, so y2 minus y1 over x2 minus x1. And our y's are units are beats per minute. And then our x's have a unit in years. So this is going to help us determine our units when we put it all together in the end. But now let's also make sure we can find the slope. So we need to identify our y's and our x's. So these are both y values, and the 20 and the 50 are both x values. It doesn't matter what you pick to be your y1 and your y2, or your x1 and your x2, as long as they're correlated together. So if I pick this to be my x1, that means the y next to it is also my y1. So that means this is x2, and then that's y2. So now we're going to substitute it into the formula, and we will get 150 minus 180 over 50 minus 20. And then now we're going to simplify it. So 150 minus 180 is negative 30. 50 minus 20 is 30. The same number is simplifies to 1, but we've got a negative out front, so it's negative 1. So now, in the context of this situation, we need to see what this means. So we're going to use this piece of information to help us. We're also going to take a look at this negative. So we can see it's going down, so we could say it's decreasing. So the person's heart rate is decreasing because it's negative. And we're going to say it's decreasing 1 beat per minute. And then we're also going to, again, see this division bars per 1 beat per minute per, again, year. The 1 coming from the slope here. Example 2. The height of a plant Y in centimeters after X days is a linear relationship. The points 30, 15, and 40, 25 are on the line. So we are going to find our slope. M equals, we're going to use the formula y2 minus y1 over x2 minus x1. And we need to identify what our y's are and what our x's are. And in this, our dependent and our independent variables. In this situation, it's very, very nice because it does tell us x days and y in centimeters. So our y's are going to be centimeters. And then our x's are going to be days. So when we're going to figure out our slope, our unit is going to be centimeters per days. So now we're going to take our points and perform the slope formula. So if this is x1, that's y1, x2, y2. So let's do 25 minus 15 over 40 minus 30. And then we have to simplify. So 25 minus 15 is going to give me 10. And then 40 minus 30 is also 10. So when I simplify the same number with the same number, I get 1. So we're talking about the height of a plant, so we need to keep that in mind. And it's 1 centimeter per day. And it's a positive number. So if it's positive, that means in the context of the situation, we're talking about a height of a plant. The plant's height is growing. So the plant grows, our slope, 1 centimeter, our dependent variable, per day. And that is how we can interpret the slope in that situation. Example 3. So the table shows the year and the cost of sending 1 ounce letters in cents. So we have our years, which they tell us is X, so that's our independent variable. And then our cost in cents is then our dependent variable. It's all represented in this table. So I do want to think about this a little bit closer, these values, because it says years after 2000. So this 3 doesn't just stand for 3 years. It really stands for this very specific year of 2003. This is 4 years since 2000. That's 2004, 2006, 2008, and then 2013. We can also think of these as ordered pairs, which is going to be helpful when we're using the slope formula. So this is really the ordered pair 3, 37, 4, 37, 6, 39, 8, 42, and then 13, 46. So now we are going to take those values and we're going to find the slope from 2003 to 2004 and 2004, 2006, 2006, 2008, 2008 to 2013. So we're going to find the slope 4 different times. And then we're going to also have to make sure that we interpret it in context. So for this first example, I'm going to be using 2003. So this ordered pair to 2004 and that ordered pair. So I'm going to say this is my X. This is my x1, x or y1, x2, y2. So it'll be 30. My slope is m equals 37 minus 37 over 4 minus 3. 37 minus 37 is 0 over 4 minus 3 is 1. So our slope is really 0. And we have to think about the units now as well, which is our dependent variable over our independent. Remember, y's over x's. So my y's are cents. And then my x's are years. So we can put it all together and say that from 2003 to 2004, The cost of sending 1 ounce letter changed 0 cents per year. We can continue to use that same idea, the cents per year for the next one as well. So let's go from 2004 to 2006. So now we're using these ordered pairs right here. So I'm going to say this is my Y2. So M is equal to 39 minus Y1, 37, over X2 minus X1. So that's 6. Oops. 6 minus 4. So then I get 39 minus 37 is 2 over 2. So that's really equal to 1. So now from 2004 to 2006, it's changing 1 cent per year, or the cost is increasing 1 cent per year. I would like you guys to pause the video here and try C and D on your own. Find the slope. For part C, you get 3/2, which you can rewrite as a decimal as 1.5 or 1 5/10. And it just kind of flows better saying 1.5 cents per year than 3/2 per year. Similarly, for part D, you get 4/5, which can be written as a decimal as 0.8 or 8/10. And so you're increasing 0.8 cents per year. I would like you guys to take a look at these on your own. Make sure you find the slope and then also write a sentence with the correct units. So pause the video here and give them a go. So in this example, we are exploring the relationship between temperature in degrees Fahrenheit to degrees Celsius. We have our slope formula. Our y's are our degrees Celsius, as you can see on the y-axis. That's our dependent variable. Our independent variable is our degrees Fahrenheit, as you can see here on the x-axis. We perform the slope formula given the points that we have. I simplified it by dividing the numerator and the denominator by 3 to get 5/9. So the temperature increases 5/9 degrees Celsius per degree Fahrenheit. Example 5, the number of cubic feet of water Y in a reservoir X hours after the water starts flowing into the reservoir is a linear function. It gives us these 2 points, and it says it's on the line. So we have, again, our slope formula. The unit of our Y variable is cubic feet. The unit of our X variable is hours. So Y over X, cubic feet per hour. We perform the slope formula and we get 50, which is a positive number. So it tells us the water in the reservoir is increasing because it's positive, 50 cubic feet per hour.